This is a video where I go through some of the proofs that are in section 5.2. There were a handful of proofs, so I thought it better to put them in their own separate video so we could practice doing some proof writing here. So this proof, we're just going to write out the missing parts here, but it says that the given is that the angle MQP is congruent to NPQ and angle MPQ is congruent to angle NQP. Okay, that's a handful. I really like to be visual about these, so I'm going to go ahead and highlight these and show that they're congruent using our congruence marks. Since they're angles, we'll use that little arc mark, and we'll do a double arc mark for this second congruence that's given as well. So angle MQP means this angle, so I'm going to go ahead and put a little mark, noink. And then I have another angle, angle NPQ. So NPQ means this angle here, boink. You can switch colors if you want, but I'm still going to do a double mark. This one says angle MPQ, so MPQ is this one here, so I'm going to do a double mark, is congruent to angle NQP, so this one here. Okay, cool. So now it's a little bit easier to see what's congruent to what. And finally, the only other thing it's asking here is that we have to prove that MQP is congruent to NPQ. So we have to prove these two triangles congruent. Well, our first step is to write down the givens, but hey, it did it for us. That's cool. So we know that these two things are, this is congruent, those are our givens. And then finally, just a hint, since we're in the angle, side, angle, triangle congruence section, our last statement that these two triangles are congruent, we'll use angle, side, angle, triangle congruence theorem. Well, I know this angle is congruent to this angle, and this angle is congruent to this angle. So there's our two angles. What do we need? What do we still need to use angle, side, angle? We have the A's basically, but we need this S. S stands for side. So is there a side on the top triangle that's congruent to the side on the bottom triangle? Yes, there is. And it happens to be the included side. What luck? It's this side here. What's the name of that side? Well, it's QP. So we can say that QP is congruent to QP. Pretty obvious, right? But it's actually one of the properties of congruence. I'll go ahead and pause here while you look it up, since I don't think we've used this one before. Pause. That's reflexive property. The reflexive property of congruence simply states that things are congruent to themselves. So we can say that this side here is congruent to itself because it's part of both triangles. So that's pretty cool. So our proof here works pretty well. We have an angle. Note here that the order doesn't matter what order we prove them in. We proved angles congruent, then a side's congruent, one side congruent to itself, to the other side of the other triangle. Therefore, the two triangles are congruent. But before we could make this conclusion, before we could use angle, side, angle, up above and in the proof, we had to come up with a congruence for a pair of sides, a congruence for a pair of angles, and a congruence for a pair of angles. So keep that in mind. Whenever we use angle, side, angle, these three things need to appear somewhere above it in the proof. Okay, so B here, angle A is congruent to angle C. I'm going to mark that. Angle A is congruent to angle C. Also says E is the midpoint of AC. E is the midpoint. How do I mark a midpoint? Well, I'm actually going to kind of skip ahead here and go ahead and move on to the definition of midpoint. Remember how we said that using our definition of midpoint, we know that it's in the very center of segment AC. So therefore, AE and CE are congruent. So I'm going to put a little mark there. It's kind of skipping ahead on the proof, but note here that it's not super derived, right? All I'm saying is that this is my mark for the given information, so I remember that, oh yeah, that's part of it. So we know that AE is congruent to CE, but we'll have to derive that here in the proof. So this one here, given, Then finally, we can say E is a midpoint of AC. That also was given. So how did I figure out that AE is congruent to CE? Well, again, it's the definition of a midpoint. Then I can say that I'm missing one more thing to use angle side angle, because I am going to use angle side angle. What is that thing? Remember, I have an angle is congruent to another angle. I have a side is congruent to another side. So I have an angle, a side. I'm missing one more angle. Well, hey, look, I could show that maybe angle B is congruent to angle D. True, I could show that, but then I couldn't use angle side angle, because remember, I need the included side between the two angles, and this angle here makes it so the known side isn't included. So that angle won't work. Not for ASA at least. Or at least not a nice, simple, easy, direct step. So let's look at this other one. Let's look at this angle here. Maybe this angle is congruent to this angle. Oh yeah, we have a reason to say that. Just by looking at the figure, we can tell those are vertical angles, and the vertical angle theorem says that vertical angles are congruent. So yeah, it did say vertical angles theorem, but vertical angles are fine for our reasoning there. It's also fine to just put ASA. You don't have to put the whole triangle congruence theorem. I'm happy with you just writing down ASA. In part B, suppose the length of AB is 8.2 centimeters. Is that this one? No, I don't know what that's about. Okay, why don't you go ahead and do this one? Pause here while you fill in as much as you possibly, and then we'll check. So pause. Okay, that's paused enough. This one here, our givens are JLM. So again, I'm just going to mark on here. JLM is this whole angle. Whoa. Is congruent to angle KML. KML, which is this angle here. And then JML. JML, which is this little one. Double mark. Is congruent to KLM. Again, I'll put a little double mark. Hard to see. Okay, so I have these two triangles. The thing that I'm trying to prove is, I covered it up, but you can see it. It's that the two triangles are congruent, right? This is the section we're in here for the book. And in fact, we'll do lots of this sort of things for the next 2 or 3 chapters. So what's the first thing I can say? Well, it's the given, right? JLM is congruent to KML. That's given. Given. So really, this shouldn't be too hard. I'm going to prove this. So that goes down on the bottom. What's my reasoning for that? Angle side angle, right? Since, again, this is the section of the book we're in. And again, I can figure out what that missing piece of information is. Do I have an angle? Yes. Do I have an angle? Yes. What am I missing? I'm missing the side. I am missing side. It has to be the included side. It's side LM. So side LM is congruent to side LM. And what's my reason for that? Hopefully you figured out, again, from the previous example, it's reflexive property. So the reflexive property of congruence. Cool, one more proof. See if you can do this one. So pause here. I don't know why I covered this up. What given information will there be? Oh, I think I was supposed to cover that. Okay, doesn't matter. We have angle S and angle U are right angles. Again, I'm going to mark it. Angle S and angle U are right angles. RV bisects SU. So RV, this whole segment here, bisects SU. So note here, when we're talking about RV bisecting SU, which one is being cut in half? It's SU. It's the one being bisected. SU is being bisected, therefore I know that I'm just going to go ahead and mark this now. I'm going to say that ST is congruent to UT. So that's going to come up in the proof somewhere. So my first one is my first given. My second one can be, well, actually, the way they've ordered it in this book here is that S and U are both right angles, therefore they're congruent. Y, this is, again, kind of a weird reason, but right angles are congruent. They have the same angle measurement. You could put that, something like that. If it's a right angle, that means that they're equal to any other right angle, therefore they're congruent. We also have our other given information, RV bisects SU. That was a given. And then, again, this is my derived information, that ST is equal to UT. And how do I know that? That's the definition of a bisector, because this section here is being bisected. So, if we're proving the two triangles congruent, using angle side angle triangle congruence theorem, again, there's one piece of information left. I have an angle, I have a side. What am I missing? I'm missing an angle, and it happens to be this angle here. Well, are those two angles congruent? Yes. I can write them out. Angles RTS and VTU. The reason is that they're vertical angles. Cool, that's it. That's all I got for the proofs. Good job if you stuck with me on that. Thanks.